Good morning and happy Monday. This is our last week before February vacation. This week we're going to continue to focus on solving equations, and we're going to start the week off by focusing on equations that have fractions in them. The big first thing we need to understand about any equation with fractions or decimals, which we're going to talk about later this week too. They're solved using the same exact process we learned the last 2 weeks when the equations had integers or whole numbers. The only difference is now we're going to need to remember how to add, subtract, multiply, and divide when we've got fractions and decimals involved in our equations. So it's going to be important to remember back in 5th grade, 6th grade, some of the rules you learned for how to multiply and divide with fractions, how to add and subtract with fractions. But other than that, it's going to be the same work that we started to learn last week and the week before that. Finally, today and tomorrow, we're also going to explore a second option when you see fractions in the equation, how we could potentially multiply by the least common multiple, which we'll talk about again later in class today and more on Tuesday. And multiplying by the least common multiple is one way to eliminate fractions from your equations. You'll see that option later today when you're working on practice problems. Okay, for the first guided problem, which you can see on my whiteboard here today, you're asked to first explain, so you're going to be writing a sentence, explain your method for adding and subtracting with fractions. I'd encourage you to talk to your neighbor or someone at your group right now and think back to how did we add and subtract with fractions, and then either on your own or with your neighbor after you talk about how you add or subtract with fractions, go ahead and figure out how to add and subtract when some of these like terms involve fractions. Welcome back. Before I go full screen on this whiteboard, I'm just kind of going to write my explanation in here. Hopefully after you and your neighbor discussed, or a couple people at your group, you talked about something really important, and that's a common denominator. Everything when we're adding and subtracting with fractions, or what I call combining like terms, comes down to, do they have a common denominator? If the fractions do have a common denominator, like 1/5 x plus 3/5 x, you should remember all we need to do is add the numerators. 1/5 plus 3/5 gives us 4/5 x. Again, if we think about a fractional diagram that had fifths in it, that's not the best drawing ever, but 1, 2, 3, 4, 5. If we had 3/5 and then we got one more fifth, we would have 4/5 at the end of the day. So hopefully you remember, if the common denominator is present, anytime we're adding or subtracting with fractions, it's pretty straightforward. All we need to do is add the numerators, and the denominator stays the same. The more complicated situation, and hopefully this was part of your explanation, hopefully you talked about when they don't have a common denominator, you need to work to find the common denominator, and that again has to do with least common multiple. What's the smallest number that 2 and 4 both multiply evenly into? It's 4. So I'm just going to switch 1/2 to 2/4 y plus 1/4 y, because I recognize that if I could get this to something over 4, and that 2 could just multiply by 2 to get there, 2/4 y plus 1/4 y becomes 3/4 y. That wasn't my best explanation ever. If you've got questions about when the denominators are not common, how we can get them to have a common denominator, please talk to your neighbor about it or put your name on classroom Q, see me or Miss Stewart. But this becomes 2/4 y plus 1/4 y, and that would give us 3/4 y at the end of the day. Last example here. Again, we see two fractions, 5/6 m, negative 1/3 m, and a positive 2. I'd note that 3 terms are here. 2 in blue boxes are variable terms, and the red circle is a constant term. So I am allowed to combine these two like terms, but I would not be allowed to combine this m with the positive 2 because they're not like terms. 5/6 m minus 1/3 m, adding and subtracting with fractions, same rule, they need a common denominator. The least common multiple of 6 and 3, the smallest number they both evenly go into, is 6. So I can switch 1/3 m, negative 1/3 m, to negative 2/6. I multiply the top and the bottom by 2, and now it has the common denominator, 5/6 m. I still have the plus 2 there, that can't get involved, but now 5/6 minus 2/6, that's just Same thing with adding with common denominators. When we subtract numerator minus numerator gives us 3. The denominator stays the same. I get 3/6 m plus 2. And you should simplify 3/6 m at the end of the day to 1/2 m plus 2 is your final answer. Okay, now moving on to part 2 on your own. You and your neighbor are going to explain your method for multiplying a fraction with an integer. Integer means whole number. Again, sometimes when we're solving equations and there are fractions involved, like the 2 examples we see below, you're going to have to multiply your fractions with integers or whole numbers. So write an explanation after discussing with your neighbor, how did we multiply fractions with whole numbers or fractions with integers? And then on your own or with your neighbor, you're going to transform both of the expressions here. They're in factored form, and we want to transform them into expanded form by multiplying with these fractions. As you and your neighbor are discussing, hopefully you wrote in an explanation, you discussed with your neighbor, and then you both figured out how to transform this into expanded form. The explanation: whenever I multiply with fractions, the big key, you multiply by the numerator, then divide by the denominator. We're going to discuss that a little more. I spelled numerator wrong. So when we multiply by the numerator, that means we're going to multiply by the top of the fraction, and then we just divide by the bottom. So as I go into full screen here, 1/4 times 20 and 1/4 times -12n, you'll notice this is a constant term and this is a variable term. I cannot combine them, but I can distribute or multiply 1/4 with each of that constant term and then the variable term. Multiplying by 1/4 means I'll multiply each term by 1 and then I'll divide by 4. Multiplying by 1 won't change it, so anytime I multiply by a fraction that is 1 over some number in the denominator, I'm really just dividing by the denominator. 20 divided by 4 is 5. -12 divided by 4, a negative term divided by a positive term over here is going to give us a negative answer. 12 divided by 4 gives us 3. So 1/4 times -12n is just like taking -12n, dividing it by 4, and that would give you -3n. Over here, a little more complicated because now we have a number other than 1 in our numerator. So I'm going to have to multiply everything by 3 and then divide by 2. And keep in mind, this is a negative fraction. So a negative times a positive gives us a negative. 10 times 3 is 30. 30 divided by 2 is 15. We get -15p. I could see that down here. We'll show that out a little bit better. -3/2 times 10/1. 30/2, and that's going to be negative, and 30 divided by 2 is 15. So again, you see our shortcut of just multiply by the numerator, then divide by the denominator. 10 times 3 is 30. 30 divided by 2 is 15. Is the same thing that happened when we wrote this out the longer way. -3/2 times -4. Whenever we have a negative times a negative, we get a positive answer. 4 times 3 is 12. 12 divided by 2 is 6. We also could say 4 divided by 2 is 2, and then 2 times 3 is 6. Either way, we see -15p plus 6. If you and your neighbor struggle to follow that, please grab me or Miss Stewart, put your names on Classroom Q, but hopefully this is familiar on how we multiply integers or whole numbers with fractions and how we handle negatives when we multiply as well. Okay, your last job. Again, you're going to be pausing the video, working with your neighbor on part 3. For part 3, your first job is going to be to recall how do we divide by a fraction, and then you're going to solve each equation below. Because I'm down to 30 seconds, I'm going to pretty quickly just show you the first example. Hopefully you pause the video, work this out on your own. When we divide by a fraction, the big key is to remember dividing by a fraction means we just flip to the reciprocal and then we multiply. 1/2 x equals -20. So the inverse operation here would be to divide by 1/2. That's the opposite of timesing by 1/2.